Welcome to Seagull Maritime's video on safe mooring operations. In this video, we look at the characteristics of common mooring ropes and how to handle them safely. Throughout, you will be asked to pause the video and reflect on what you've seen and heard. Ideally, you should watch this with at least 2 of your colleagues so that you can engage in group discussion.
Echa acá, voy. Ya échalo. Ah, no. Echa. Sí. Pero no tires mucho porque no te va a llegar ahora. O sea, estamos a 8 metros todavía, ¿no? No. Hey. No me gusta. ¡Ay! Ya, que demasiado, tío. Es una burrada, tío.
When a rope is under tension, it stretches. Depending on the material, this can generate a lot of stored energy. As a general rule, the more stretch there is, the greater the stored energy. If the force is beyond the braking load, it will fail. The energy suddenly releases when the rope parts, causing the 2 ends to fly away from the brake point. Mooring lines are made up of wire or fibre. Let's take a look at the stretch of some of the more common materials as they fail, based upon a 50mm diameter sample. Steel is used to make up wire ropes, and this will break at 150 tons with 2% stretch. Most fibre ropes are made up of synthetic materials, which can all stretch and fail at various levels. Polypropylene is a very common material to use for mooring ropes, though it is not recommended by OCIMF to be used on tankers as the main mooring line or a tail. It floats and is as elastic as polyester, but it has relatively less strength. Due to its low melting point, it is prone to fusing under friction, and it suffers from actinic action, causing the material to degrade in sunlight faster than others. Polypropylene lines will break at 31 tons, with a stretch of 20%. More commonly known as nylon, polyamide is heavier than water, and so it sinks. This can be an issue as it loses strength when wet, but it is resistant to abrasion and temperature damage. Polyamide lines will break at 44 tons, with a stretch of 20%. Polyester is the most durable of all materials. It is heavier than water, but maintains its strength when wet and does not suffer much from abrasion due to its slippery nature. Polyester will break at 35 tons, with a stretch of 12%. Polyolefin is lighter than water and does not lose strength when wet. Although it has a relatively low melting point, it does have excellent abrasion resistance and is reasonably strong. Polyolefin lines will break at 41 tons, with 20% stretch. High modulus ropes are considered as an alternative to steel wire rope. Used extensively as mooring ropes and tug lines, there are various terms associated with them, such as high modulus synthetic fibre, high modulus polyethylene, and ultra-high molecular weight polyethylene, as well as brand names such as Kevlar and Dyneema. With the exception of Dyneema, they don't usually float, but they are very strong, have low stretch, and little snapback. A Dyneema line will break at 193 tons, with a typical stretch of 3.5%. Some ropes consist of a mixture of materials, such as polyester and polypropylene. Their characteristics can be found by referencing the manufacturer's information. These mixed fiber lines will typically break at 49 tons, with the amount of stretch variable depending on the mix. On some vessels, an elastic mooring tail is attached to the wire or high modulus polyethylene mooring line. This section takes shock loading, protecting the mooring fittings and the main mooring line from damage, and it is easier to handle than a wire.
On board your vessel, are the crew aware of the type and characteristics of the mooring lines? Do they treat them accordingly, or are there any extra precautions that could be taken? Click the pause button and start your discussion.
The snapback zone is a general reference to an area swept out by a parted line. The two ends of the broken line initially recoil away from each other in the direction of the line. If a rope breaks at the point it changes direction, such as around a roller or fair lead, it will recoil and then whiplash in a radial direction. Before any mooring operation, you should take part in a toolbox talk to identify snapback areas. These will be reduced if the mooring plan minimizes the use of pedestals that cause mooring lines to lead in various directions. A rope under tension around an object is weakened due to the radius of curvature, and so it is very important to use rollers and fair leads of the correct size for the rope in use, although it is not a problem if they are oversize. But problems occur when they are undersize, as too small a radius exerts too great a stress and causes the rope to part more easily. Some vessels try to identify these hazardous areas by painting snapback zones on the deck, around posts, fair leads and winches. However, according to the UK Code of Safe Working Practices, the painting of snapback zones on mooring decks should be avoided because they may give a false sense of security. As snapback zones are very difficult to forecast accurately, you should consider the whole of the deck dangerous. Snapback ropes can inflict serious damage in a very short time, reaching speeds of up to 500 miles per hour. Even so, complacency can be an issue with a routine mooring operation. It is essential that throughout, the crew are reminded of safety. Snapback zones also differ depending on the type of rope. A very stretchy material has lots of stored energy, causing a large reaction and snapback when it fails. Ropes with little stretch, such as HMPE, only have a small snapback when they fail. However, if this type of rope is connected to a mooring tail of a different, more elastic material, as is often the case on a large vessel, the stored energy in the intact tail can cause the other rope to snap back violently. It is recommended that gloves are worn for general handling of wire, but you should check your company policy to see if they should be worn when handling a wire during a mooring operation. It is possible that a wire snag can catch on a glove, trapping the hand and the person, and pulling them towards the vessel's side or an item of machinery. When working synthetic ropes, gloves increase the chance of having a hand trapped by a rope or in rotating machinery. Having close-fitting gloves and not getting close to rotating equipment minimizes the risk of trapping clothing. Before use, a rope should be removed from a storage reel, because it is not designed to turn at the high speed that is experienced when the rope pays out. Also, it may not have a brake system that enables it to be controlled. Some ropes are designed to be left on storage drums whilst being deployed, as the drum is powered and used to both haul and store the rope. Split drum winches have a hauling or traction drum attached to a motor, as well as a storage drum alongside to hold the spare rope. They are designed for the rope to be left on whilst it is being worked. Flaking a rope is an expression that relates to a line taken from a storage reel or storeroom and laid on a deck in sections, side by side to each other. The line is able to run freely when being deployed. However, there are dangers associated with a flaked rope. It becomes a trip hazard, and if crew stand in a bight as it is moving, they can be thrown off their feet or become trapped. A rope that is flaked on a deck and being paid out will possibly be moving at a very high speed, particularly on a vessel with a high fare lead. If a crew person attempts to stand on it, they can be knocked off their feet. If they attempt to grab it, they can be thrown into mooring equipment or over the side. And a rope burn is also possible when gloves are not worn.
Are all crew aware of the snapback zones on board your vessel? Do they avoid them when ropes are being hauled? Click the pause button and start your discussion.
Now that we have looked at the types of mooring rope that are used and how to handle them safely, let's look at the good practice that will help ensure a safe mooring operation. When using a synthetic multi-plat mooring rope, it's important that you correctly apply a two-legged synthetic stopper. As these are not as strong as mooring ropes, a stopper should not be used to hold excessive weight. Also, it should never be left attached to a mooring line when a vessel is tied up. On a wire mooring line, you should apply a chain stopper. Once a stopper is applied, the tails of the stopper can be lashed to the mooring line, or, more commonly, the tails can be held by a crew person whilst the mooring line is being transferred to a set of bits. When holding the tails of a stopper, stand aside so you're not in the line of the mooring rope or stopper in case either parts. Certain types of ropes need to be turned up on bits. If the synthetic mooring ropes are not on fixed drums, they have to be transferred to a set of bits to be made fast after they have been hauled tight. The same applies to a wire when used for mooring, but they are more likely to be on fixed drums and traction winches. A synthetic rope is turned up correctly with a turn taken around the first post, before the figure of 8 turns. This copes with high line loads better, but does cause a high load on the leading post. It is important that a windlass, winch or capstan is always manned, as the control allows powered mooring equipment to be set into motion or stopped. This needs to be done instantly for safety, as it can stop a line being overheaved. A line can be paid out if the tension is excessive, and the device can be stopped if a person gets trapped. Some control handles are self-centering, which stops the device if unattended. Others can be set and left in a run position. Although it can be common on short-manned vessels, it is bad practice to set a windlass or capstan running and then work a rope with the control unattended. When heaving a synthetic rope on a drum end, you should use no more than 3 full turns. This allows the drum to grip the rope without applying excessive force. More than likely, excessive force will result in the rope suddenly slipping on the drum end, pulling the crew member holding it towards the drum end, or, at worst, over the top of it. The sudden slip can also cause high temperatures in the rope, which can damage low melting point fibers. It is recommended that you stand far enough away from the drum end to be safe when hauling a rope. Get a second person to coil down the excess line, and do not stand in the bight of the line, whether you are hauling or coiling down.
Is the control handle for the hauling device used on the mooring deck always manned? Is there always effective communication with the controller, or could it be improved? Click the pause button and start your discussion.
It's important to have equal tension on deployed mooring lines, so that an individual line is not overloaded. If a headline, a breast line, a spring line, or a stern line is overloaded, it is possible that the line will part, endangering personnel, causing damage to the ship, and adding stress to the remaining lines. Tension on lines can change for a number of reasons. Loading and discharging can alter the vessel's draft. Tidal effects can raise and lower a vessel relative to the jetty, and the wind can also affect the line's tension. Likewise, a previously secured line can slacken if there is slippage on a mooring bit or brake rendering on a winch. And a line parting can alter the tension of those remaining. Ship-to-ship transfer operations can also affect line tension, as can waves causing a vessel to roll alongside. When a vessel is made fast, lines must be evenly tightened. If lines are on drums, it is a relatively easy task to haul each of them to a set tension. It is more difficult if ropes are hauled manually on a drum end and transferred to a set of mooring bits. As some tension will be lost when the rope is stoppered off and transferred to bits, it is good practice to slightly overheave a rope compared to the others made fast, knowing that some tension will be lost in the transfer. Mooring ropes should be continuously monitored on a vessel whilst it is alongside and adjusted when necessary. If you see a slack line or one that has become too tight, report it to the officer in charge. Check to see if the ropes have been chafed and that anti-chafe mats are still in place. It is also good practice to fit rat guards properly at all times. Mooring operations are one of the most important tasks seafarers will complete on a ship's deck. They may seem like simple operations, but there are numerous dangers that you must always consider. Think safety at all times to look after yourself and others.
Is there anything that can be done to enhance the safety of a mooring operation? If there is, how do you go about getting practices changed? Click the pause button and start your discussion.